Hello, welcome to MSR Math classes. As we are continuing with differential equations, in this video you can find out methods of solving first order and first degree differential equation. So before going to this one, what is order of the differential equation? What is the degree of the differential equation? I have discussed in my earlier videos. Please watch them. I am sharing the links for that. Please do watch it. And now here in this case, we are going to solve the first order and first degree differential equation. Means the standard form of first order first degree differential equation is dy by dx is equal to f of x comma y. So if you see, this is a function in x comma y and dy by dx is there. So the order of this differential equation is 1. The highest derivative is dy by dx. So order is 1 and its power is also 1. So it is first degree. So this is the standard form of first order first degree differential equation. So standard form of first order and first degree differential equation. So whenever we get this one, how do we solve it? This is what our aim now. So such kind of differential equations appears, then how do we solve it? Solving first order first degree differential equation, right? So in the last exercise, what we did, if there is any curve is given, whether it is a solution for the given differential equation or not, we have checked, right? There you know both the solution curve as well as differential equation. It was very easy job for us to find out its differential equation, to find out whether the given curve is a solution or not for the differential equation. Whereas now we have a differential equation. For this one, the curve, solution curve, we need to calculate. So to calculate that, we have different methods. So let us discuss one by one. The first method here is, first method is variable separable method. Okay. So to solve a first order first degree differential equation, we use 3 different methods. Like there are many methods also, but in CBSE syllabus, there are only 3 methods that we are going to discuss in this. So variable separable method, homogeneous method, and linear differential equation. Okay, so there are 3 kind of differential equation that we are going to discuss, and in this particular video, let me go with the exercise 9.4 variable separable method. Yeah, before entering into the exercise, let me brief about variable separable method. The name itself says variable separable, means you are separating the variable. How is that possible? Let's see that. So first one, variable separable method. So as we are going with the standard form of differential equation, first order first degree differential equation, you can ask me, is that only, there is only first order first degree differential equation is there? No, you will have plenty, but we are going with the basic one. We have first order first degree. In that case, how do we solve that? Those methods we are going to learn one by one. Yes, for the first order first degree differential equation, the variable separable method, how do we solve? Let us see. So here in this case, f of xy, if it can be written as g of x into h of y, means f of x comma y is mentioned, right? If you can split as the function in x, function in y, then we can go ahead with this method. Okay. In that case, we can continue with dy upon h of y, g of x into dx. Okay. So whenever, can you see now the variables are separated? Once the variables are separated, the method is to find out the solution is integrating on both sides. So integration dy by h of y is equal to integration g of x dx. So if you know the formulas, integration formulas, this method is the easiest method, I can say. You can solve the questions very easily. Yes, let's move to the further exercise questions of CBSE textbook. First exercise, first question, exercise 9.4, I should say. Exercise 9.4. The first question, there it was asked for each of the differential equations in exercise 1 to 10, find the general solution. So we need to find out the general solution. So just now I told you the method, use that the same method and find out its general solution. So dy by dx is equal to 1 minus cos x by 1 plus cos x. So first of all, is it a first order first degree differential equation? Yes. And can we see this one is a standard form, dy by dx is equal to f of xy. Moreover, a y term is not there. Only x function is in x is only there. So our job is easy. Already function in x into function in y. Y is y power 0 I can put, right? So the variables are separated by writing dy equal to 1 minus cos x by 1 plus cos x into dx. So once the variables are separated, what I told you, we should do the integration. Integration dy equal to integration 1 minus cos x by 1 plus cos x. As we know, 1 minus cos x is nothing but 2 sine square x by 2. The formulas you please recall. And 1 plus cos x is 2 cos square x by 2 dx. So 2 will be get cancelled. Once we find out the integration, the answer, that is the general solution. So integration dy means integration 1 dy, which is y, and integration tan square x by 2. Can I write down tan square as secant square x by 2 minus 1? Why we are writing? Because integration tan square we don't know, but integration secant square we know. So that's why tan square is converted as secant square x by 2 minus 1. So this is integration secant square x by 2 minus integration 1 dx. So integration secant square is, careful here, secant square x is tan x, but secant square x by 2 is. So secant square x by 2 integration is tan x by 2, the whole divided by inner function. Here of course x by 2 form is there, that derivative should be written in the denominator, 1 upon 2 minus x plus constant. So which is exactly y equal to 2 tan x by 2 minus x plus c is the general solution. I hope you understood. If you understood, we'll go with the next question. Otherwise, you can watch it again. Second one, dy by dx is equal to square root of 4 minus y square, where y lies between minus 2 and 2. So here for this case, can you say dy by dx is equal to f of xy is only a function in y? So we can separate the variables as this way. Dy upon root 4 minus y square equal to dx. After this one, just integrate on both sides. So it is in the form of integration 1 upon root a square minus x square dx. This particular one. This formula it is. This form it is. Which is equal to sine inverse x by a. So by using this formula, one can write down this one as, careful, here it is in x, here we have in terms of y. And of course, the a here is 2. 2 square, 4 can be written as 2 square, right? So this value is sine inverse of y upon 2 equal to integration 1 dx, which is x plus c. So this is the answer for the second one. And the third one, the given differential equation is of this form, dy by dx plus y equal to 1. So how do we convert? We need to write it in the standard form. For that, dy by dx is equal to 1 minus y, right? Now, the right hand side is only a function in y. So I can separate the variable as by writing this way, dy upon 1 minus y equal to dx. After this one, integration on both sides. So integration of 1 minus y. Or, of course, here minus y is there. So this integration is log of modulus 1 minus y divided by minus 1, because y is having negative coefficient. If you are not able to understand this one, let us go with in deep. Here I am going to consider 1 minus y is equal to t. Okay, and differentiating on both sides, minus dy equal to dt, right? Or dy equal to minus dt. Now left hand side part you are going to convert entirely in terms of t. So dy is minus dt. So minus dt upon 1 minus y is t. So can you see now, earlier one is a complicated function. Now it is integration 1 by t dt, which is log t. So minus log of modulus t equal to integration 1 dx is x plus c. Now you can substitute back this t value, which is 1 minus y. So therefore, the solution of the given differential equation is this. The next question, problem number 4. Find the solution of the differential equation secant square x tan y dx plus secant square y tan x dy equal to 0. So first thing is we need to try to convert this. Since we are only one method now, we have to go with variable separable method, and that to apply that we know already that we have to separate the variables, right? So I'll to separate the variables, I will do one of the thing. Here I am going to write down the one of the term on the left hand side, the other one on the right hand side. Okay, like this. Now be careful here. There is one of the important thing I should tell you. All dx term should be there in the numerator only. Do not bring dx term to the right hand side. Wherever dx term is there or dy term is there, keep them there only. According to this derivative term, the variable other functions to be moved. So here secant square x is there, write it dx, and tan y move to the right hand side. So minus secant square y by tan y, and here tan x is there, move to the left hand side, divided by tan x dy. So can you see now the variables are separated? After separating the variables, what do? We do the integration on both sides. You can clearly see tan x derivative is secant square x, tan y derivative is secant square y. We have a formula integration f dash of x by f of x. What is this integration? By substitution method one can do, or if you remember this formula, it is enough. Integration f dash of x by f of x dx is log modulus of f of x plus c. So this integration is log of modulus tan x plus c, and here minus log of modulus tan y plus c. So therefore the solution here is log of mod tan x plus log of mod tan y. So when I was equal to c, this c I can write it as in terms of some log c1. Okay, every constant can be written as in terms of logarithm. Of course, here c I have written as log c1. So this is nothing but log m plus log n, which is log m into n. So log tan x tan y equal to log c1, which is equal to tan x into tan y equal to c1. So this is the required solution. Okay. Let's go ahead with the question number 5. Find the solution of the differential equation. Question number 5. The solution of the differential equation e power x plus e power minus x into dy minus e power x minus e power minus x dx equal to 0. So I am going to separate the variables by first of all by writing the given equation in this format. This is equal to e power x minus of this term if I send to the right hand side, We'll get this one. Now, this is the function in x, right? So we'll move to the right hand side. So dy equal to e power x minus e power minus x upon e power x plus e power minus x dx. Now, variables are separated. Once variables are separated, we need to do the integration on both sides. The right hand side part should be solved. So for this one, to solve this one, I am going to consider the denominator. Let us consider e power x plus e power minus x as t. Okay. Now do the differentiation on both sides. E power x differentiation is e power x. E power minus x differentiation is minus of e power minus x dx equal to dt. So you can clearly see whatever the function is visible in the denominator, that differentiation is there in the numerator. That is what we can see, right? So it is exactly in the format of integration e power x minus e power minus x dx, this numerator part it is. Okay. This part can be replaced by dt and 1 upon t. So it is integration 1 by t, which is log t, log modulus t. So left hand side we have integration 1 dy, which is y. So therefore y is equal to log of modulus t here is e power x plus e power minus x plus constant. So this is the general solution. And the next question is problem number 6. Dy by dx equal to 1 plus x square into 1 plus y square. It's easy, very easy. The right hand side f of xy is written already g of x into h of y, right? So I can easily bring the 1 plus y square to the left hand side, 1 plus x square as it is into dx. Now the variables are separated, integration on both sides will give you the general solution. The left hand side integration 1 by 1 plus y square, which is tan inverse y. Be careful, here we have in terms of y, so we have to write down the antiderivative in terms of y itself. And integration 1 plus x square. So integration 1 dx is x and integration x square dx is x cube by 3. So this is a required general solution. And question number 7. Y log y dx minus x dy equal to 0. So here again I am trying to separate the variable here. Y log y dx equal to x dy. So which term to be moved? Dx cannot be replaced or dy cannot be moved anywhere. We have to keep it as it is. According to the derivative which is present in the numerator, the other function, means functions in x to be brought to the derivative of x terms. So dx, that means exactly what I mean to say, dx is there. So x function, here only x is there. That I am bringing to the left hand side. Dx upon x is equal to dy upon y log y. Now, can you see the variables are separated? Yes. Once the variables are separated, integration on both sides. So, integration dx upon x. So, I can write down the this part as integration 1 upon y by log y dy. Okay. Why am I writing like that? You will understand. By the way, integration 1 by x is log x. Here, if you see, this is nothing but in the form of this integration f dash of x by f of x. And we know the formula of this one is log of modulus f of x. Okay. So, why I have written like this? Because log y is a function and its derivative is 1 by y, that is present in the numerator. So, it is in this format only. So, log of mod f of x, log of f of x, whatever is there in the denominator, that should be log of mod log y plus constant. Since these two are in terms of logarithms, the constant can also be expressed in terms of logarithms. So, log x is equal to, this is log m plus log n, which is log mn. Log c into log y I can write down. Okay. And now these both the terms are having logarithm, so x is equal to c log y is the general solution. Okay. So sometimes even the c, if you can send to the left hand side 1 by c, which is c1, you can consider c1 into x is equal to log y is also the general solution for the given differential equation. Now problem number 8, x power 5 dy by dx is equal to minus y power 5. So the variables can be separated very easily by taking y power 5 to the left hand side, dx upon x power 5. Of course, minus is there. So now integrating on both sides, y power 1 by y power 5 integration is y power minus 4 by minus 4 is equal to minus of x power minus 4 by minus 4 and plus constant. So I can multiply both sides by minus 4 and can get y power minus 4 is equal to x power minus 4 plus minus 4 into c can be written as some c1, some constant. Okay, of course here minus is there. Therefore, x power minus 4 plus y power minus 4 equal to constant is the required general solution. And the next questions you can see in the part 2. Thank you.